May I audible? May I audible? Hello. May I audible? Please give the reply. May I audible? Shivani, may I audible? Supriya, Aditya.
Yes, sir.
Okay. Okay, we cover the remaining points. I think screen is visible. Yeah. Screen is visible. Okay, in last lecture we have started the distributed file system. We have covered the architecture of distributed file system. Also, we have the completed architecture of distributed file system. Next, we start the mechanism for building distributed file system. Okay, while the file system is required, we require this file system for the communication between two or more computer systems. At the time of during the transmission of the file from one system to another, okay, we require the mounting, caching. You already know the web. For example, these are the browser. Browser can store the cache memory. It's a temporary storage memory. We require the hints, bulk data transfer. Right now in the many companies they are doing the salary, okay, within this one file system. For example, they only send the one file, excel file. Through this excel file they have completed the salary process. Same thing here, bulk data transfer means at a time we can send the number of data. And next is encryption. Encryption means we will provide the security. See here, mounting means this is the binding between the, for example, you have studied in the Java encapsulation concept. In the encapsulation, they can binding between the variable and methods. Same thing here, In the single file, they have the a number of variables and values are available. Okay, this is the mounting. Second concept is the caching. Why this caching is required? See, every time we can search on the internet, google.com. Okay. Already there are a number of users, they can search in the google.com. This Google request is stored in the cache memory. After the some time, you can search on the same request, you can send the same request. Then already this web page is available in the cache memory. They can immediately give the response. Means caching means this is a temporary storage memory. They can immediately give the response to the web browser. Means you can search the number of web pages on your Google Chrome. Okay. At the time of giving the response from the server to your web page, every data has stored in the cache memory. In after the next day, you want to hit the same request, then immediately this cache memory they can provide the web page to your machine. Next, okay, these are the hints. Hints means same like we can hit the URL. Okay. Right now, for example, in my URL, I type the google.com and I click on the enter button. This is called as hit. Means I have hit the particular URL. Next, bulk data transfer. Right now, in the many companies, they are using this bulk data transfer. At a time, they can send the number of data to the user. Same like you are the user, you can download the movie from the internet. Means right now this movie have the number of file systems are available. Okay, this is the bulk data we can download in our machines. Okay, this encryption used for the security purpose. At the time of sending the data to the receiver side, okay, we can encrypt the data, and at the receiver end they can receive this encrypted data. They at the receiver end they can apply the description technique and receiver got the original data. This is the encryption. Means in the encryption we can convert the plain text into ciphertext. Plain text means original data, ciphertext means encrypted data. And in this receiver end we apply the description. They can convert the encrypted data means ciphertext into plain text. Plain text means our original data. Okay, we have the separate we can say the okay, this related to encryption. In the next semester you have the separate subject information and cyber security. Okay, in the next semester you have the separate subject. The name of subject is information and cyber security. These are the mechanism for building distributed file system. Next is the design issues. Okay, see, at the time of designing the file system, what types of issues we have occur in front of us? The first is the naming issue, because the many files have the same name. Okay, naming and name resolution. This is the first issue. Second is cache on disk or main memory. Okay, in our browser have the cache memory. We can store this cache memory on the disk means hard disk or main memory means RAM. This is the main design issue. At the time of storing this cache memory on the RAM or hard disk, this is our main issue. Next is writing policy. At the time of designing the file system, okay, we require the policy. Policy means we can write the file or read the file. These are the policies. Cache consistency. Okay, this cache is available at the server as well as client end. Next is availability. See, at the time of transmit the bulk data to the receiver, okay, every time our distributed system provide the file system concept. Okay, in the file system, you already know the replication, you already know the duplication of the number of files. This is also main design issue. Scalability means expand the file system. Okay, for example, in the single computer we have the number of files. Okay, scalability means you can expand the file system. At the time of expanding the file system, we have the limitation. This is also one part of the design issue. Semantics means consistency. Semantic means consistency. Okay, these are the design issues. Okay, first is the naming or name resolution. Second is your cache memory. We can store the cache on the hard disk or RAM. Third is the writing policy. In the writing policy, we will decide who can read the file or write the file. Cache consistency at the client end or server end. Availability, already these file systems are available at the time of we'll see. These are the duplication or replication is available in our file. Next is the scalability. You want to expand the file system. Semantics means we will provide the consistency. Okay, these are the issues. Last point of this unit is log structured file system. See, many times you heard about this log. For example, your computer system or mobile phone, they can store the logs. All the executions are stored in the logs. Okay, in the log, see here, the disk space management. At the time of copy or pasting the files, they will provide the logs. Logs in the format of the blocks. See here, old log end and new log end. See in the diagram, they always show the logs. Okay, simply keep in mind, log means they can store the execution of the data. For example, if you run the some program in the Java compiler, okay, at the time of compilation and execution of this program, okay, after the execution, they can store the execution in the some files. These files are called as logs. Same thing in distributed file system. Okay, you can run this file system. Run means you can transfer that this particular file from one host to the another host. Okay, this transmission is going on between the two or more users. Okay, all these activities are stored in the logs. Logs means they can store the executions. Okay, same thing you keep in mind. For example, they can store the execution on your hard disk or RAM. Okay, this is the log file system, and this is the case study Google file system. Okay, means here we have completed the unit number 7. The name of unit is the distributed file system. In that, in the last lecture, we have completed the distributed resource management concept of file system, distributed file system, and today we have completed mechanism for building distributed file system, design issues, and log structure file system. And your case studies are Google file system. Okay, here we have completed unit number 7. Okay, next the unit number 8 is the distributed shared memory. We'll cover this last unit. Okay. The last unit name is the distributed shared memory. The distributed system have the total 8 units. Up to that, we have completed the 7 unit, And today we'll cover the last unit, unit number, name of unit number 8 is distributed shared memory. Right now, the shared memory concept is going on. Everybody has shared his own memory, like where is the hotspot, who can share the network. Same thing. See, in the distributed shared memory, we can share the memory virtually or physically. There are two concepts are available. Physically means we will share our RAM memory, okay, and virtually we can share this virtual also. We have the concept. Next, architecture of the implementing distributed shared memory. See here, this is the central server. These are the client. Every client, they can send the request to the center server, and center server provide the responses to the every client. Same time, if client want to extra memory, but right now in the client side they don't have any budget. At the same time, they can virtually access the memory. This memory is available on the server machine. It means in the client computer machine, they can access the memory. This memory is available on the server machine virtually. This also one type of the distributed shared memory. Same thing, you check in a company also, if your system have the less configuration, then automatically virtually your system can access the memory. This memory is available on the server. This is called as distributed shared memory. They can share the memory like hard disk, RAM. Sometimes they can share the processor also, because your existing system have the less configuration processor. This is called as client server communication. Sometimes the data can migrate from the one machine to another machine. At that time, we require the more memory. At that time, with the help of the shared memory, they can switch the data from one machine to another machine. This is called as migration concept. Migration means send the data from, migrate the data from one machine to another machine. This is called as migration. See here, data access, we can for example, this machine they can migrate the data, or sometimes we can replicate the data from one machine to another machine. Next concept is memory coherence. What is the coherence? Coherence means consistency. There are several forms of memory coherence: sequential consistency, general consistency, processor consistency, weak consistency, and release consistency. Why this consistency is required? Because at the time of sharing the data or sharing the memory, we'll check, okay, this atom we have shared or which memory we have shared, this should be consistent format. Otherwise, for example, this client machine required the 1 GB RAM, and server provide the 1 GB, but after 2 minutes they can discard this request. Okay, this is not correct. They should be consistently share the memory. This is very important. Consistency is very important in the shared memory. There are n number of types are available: sequential consistency, general consistency, processor consistency, weak consistency, and release consistency. Okay, sequential means sequentially we can share the memory. Okay, general means right now we are using the Google Drive. Why Google Drive? Because we can store the data on the Google Drive. Same thing, this Google or Gmail, they can share the memory to us. See, Google provide the 15 GB data. 15 GB memory allocation data they will provide to the every user. Means up to 50 GB, you can store the data on the Google Drive. Next processor, if you want to i3, i5 processor, at the time also with for the shared memory, we got this processor power. Weak consistency, okay. Weak is this is related to asynchronization. Release consistency means see, sometime we got this memory, okay, after our work has completed, means we must be release the particular resource. This is very important in the memory coherence. This is the release consistency, means your work has completed, you should release the particular resource. Okay, these are the memory coherence in the sequential consistency, general consistency, processor consistency, weak consistency, and release consistency. Next is coherence protocols. There are two types of protocol: a write invalidate protocol and a write update protocol. Okay, in the write invalid protocol, write to a shared data causes the invalidation of all copies except one before the write can proceed. Once invalidated, copy are no longer accessible. See here, right now, this is the shared memory is available in our network. Server provide this particular 1 GB shared memory to everyone. If this particular shared memory copy is invalid, means this is the no longer accessible by the client. I will repeat once again. Write invalidate protocol means right now server provide the 1 GB data, 1 GB memory to the all the users. If at the time of sharing this particular 1 GB, okay, they will mention this is the invalidate memory, means this copy is no longer accessible by the clients. Second is the write update protocol. Write to a shared data causes all copies of the data to be updated. Next is the design issues of the shared memory. First issue is the granularity. Okay, this granularity is the refer to the size of the shared memory unit. Okay, every file have the unit means size. We can mention this the 1 GB, 100 MB, 2 GB. Okay, first design issue is the before sharing the any files, okay, you must you must check this is the size of the file. Second is the page replacement. Okay, in page replacement, we use the concept is the LRU, least recently used. We cannot be used directly because in the page replacement at the time of sharing the files, the server side they can replace the particular page. Okay, but we can think that this page is related to particular page. They can recently use the by the particular client. This page we cannot replace because already this page is received or used by the particular client machine. Next is the case study is the Linda. Okay, see here in the distributed shared memory, the syllabus is the architecture and motivation, algorithm for implementing distributed shared memory, memory coherence, coherence protocol, and design issues. Okay, already in the introduction part, why this shared memory is required. We can share the memory by physically and virtually. This is the algorithm. The sharing between the client and server, how will happen? The client send the request to the server and server provide the particular memory to the client machine. It's the migration concept means from one location to another location, we can transfer the data or migrate the data. It's the memory coherence, sequentially consistency, general consistency, processor consistency, weak consistency, and release consistency. Next is the coherence protocols. There are two types of protocol: write invalidate protocol and write update protocol. And last point is the design issues. At the time of designing the any shared memory, we have the issues at the granularity, page replacement. And this is the case study is the Linda. Okay, you will cover this case study. This is your homework. See, here we have completed the unit number 8, distributed shared memory. Means we have completed our distributed system syllabus. We have total 8 units. First unit name is the fundamental, second is the message passing, third is the remote procedure call, fourth is the synchronization in distributed system, fifth is the distributed mutual exclusion, sixth unit name is the distributed deadlock detection, seventh is the distributed file system, and eighth is the distributed shared memory. Means here we have completed the total 8 unit. Means we have completed our syllabus. See, we have the university exam, they have the 70 marks, and IC have the 30 marks. Okay, in our syllabus we don't have external. Already your external has completed. Okay, today we have completed our syllabus, distributed system. Any doubt? If you have any question regarding the syllabus or anything, for your external, if you have any question, please those who have remaining filling the university exam form, please fill it. Also for your EBC scholarship, all of you fill the EBC scholarship form also and update on our Google form. Also related to university exam, please fill the university exam form and update on our Google Drive or Google form, sorry. Okay, if you have any question, please ask the question. Otherwise, we'll stop here. We have completed our syllabus, distributed system. We have completed all 8 units. I think in the next week, your university exam will be started. If you have any question, please ask the question. Otherwise, you can drop out. Okay, we'll stop here. All the best for your university exam, as well as all the best for your future career, like your companies. Right now, placements are going on. Okay, we'll stop here. Thank you.